Our project is called What's Wrong by Rishi Gudla and Harsh Sharma. Here's some background. Our problem is that blackouts are going to increase by 100-fold by the year 2030 due to massive power usage. U.S. electricity demand is rising and AI data centers use incredible power. There's a strain on the electrical grid and number of power outages are going to increase, and people often don't know their usage is insufficient and outage risk is rising.
So current solutions that exist include battery energy storage, which prevent blackouts during peak demand and store renewable energy via solar energy and wind energy. There's smart plug devices like Google Nest, which can help save power with smart devices, and virtual power plants. They help utilities manage energy resources, which is more of a grid level solution, not a household level solution. So our takeaway was that existing tools help, but they're fragmented and do not clearly show how households can optimize their everyday power use. Our solution, What's Wrong, is a home monitoring system that helps users understand and respond to power usage in real time. Why does this matter? It helps users learn which conditions represent high or low usage. It gives a simple, interactive way to monitor household power trends, and it builds towards smarter outage prep and energy saving decisions. So for future potential, we will replace simulated inputs with real power monitoring systems, track individual loads like HVAC lights or appliances, add neighborhood and weather-based outage risk alerts, build a household risk score based on usage patterns and local conditions, use onboard or cloud ML to recommend energy-saving actions automatically. Our goal is to move from simple monitoring to proactive household energy guidance. Thank you. Okay, so here we're using an ESP32 dev board with a breadboard in conjunction with a photoresistor, an LED, an LCD screen, and we have our Blink app connected to this using Wi-Fi. So what we're using the photoresistor to simulate power usage in a house. As you can see, it updates the light level and it changes that in the app as well to simulate power usage if there's higher use or lower use. And if we turn on this feature called Power Saver, it makes it so that the LED, as you can see, will dim based on how much power is being used. Say like right now, the most amount of power is being used. We have the LED at the brightest level, but if we simulate different energy levels, it'll decrease or increase brightness, and you can change it directly from the app. You don't have to change power usages or anything. It's live. And then we have a website here which calculates based on power usage and voltages and other things to give you a risk score. If it's stable, unstable, if your energy usage is too high or power usage, it'll switch to unstable. We can't simulate that right now because that'll be going over 25 volts and that's a bit dangerous for this circuit.